So, let us have the sample problem. Okay, so this is on variable stress analysis without the stress concentration. Okay, so you have here the sample problem. A shaft made of 4130 steel, WQT 11,000 degrees Fahrenheit, subjected to a variable torque whose maximum value is 4165 pound inch. And for a factor of safety equal to 2, determine the diameter if letter A, you have your torque is reversed, B, torque varies from 0 to maximum, and then C, torque varies from 2876 to maximum. So yung A, B, and C po na yun, it refers to yun pong types of variable stresses. Okay? So, one would be the reverse stress. Yung B po, minimum value is 0 to maximum. So, minimum value is 0. So, this is your repeated stress. Okay? And yung letter C naman po, yan po yung fluctuating. Okay? So, you have the minimum and the maximum value is given. Now, let us have the first yung given value. So, I'll be solving, okay? I'll give you direction on how to solve for letter A, and then for B and C, kayo na po yung mahala. Okay? So, let us start with the given values. So, we start with the given. Okay? So, we have first the maximum value of the torque. So, we call it the max. Equal to 4165 pound inch, or this is simply 4.165 kip inch. Okay, and then we have also, okay, material specification. We have AISI 4130 4130 WQT 1100 degrees Fahrenheit. Okay, so from our design tables, you find value of sigma u. Same thing with the value of sigma y, and then try to include also the BHN value. Okay, so we include here the BHN for it is being used to define the endurance strength, sigma n. Okay, so kuhanin po natin yung value ng sigma u, sigma y, and BHN. Okay? So, pakihanap po doon sa atin na mga design tables. Next, we'll have the factor of safety. So, maya po balikan ko sa inyo, okay, the values of these three. For the factor of safety, so we have Fs is equal to 2.0, and this is given. Okay. Okay, so Fs is given. Okay. And then for the design stress, yes. Okay, for the design stress, okay, so dito po hindi na natin gagamitin yung sigma D, okay, sigma U over Fs, sigma Y over Fs. Okay, so since this is variable stress, okay, so we are to use the Soderberg or the Goodman equation. Okay, so yun lang po yung pagpipilian natin since this is a variable stress. So how do you know it's a variable stress? Yan, yung ka-identify po dito, you have your variable torque. Okay, so indicator that the number, okay, is under a variable stress. Okay, next, need po natin malaman if the material is ductile or brittle. Kasi, dun po natin malalaman kung ano, kung Soderberg ba o Goodman yung ating gagamitin. Okay? So, in this case, we have 4130 steel. Okay? What type of material po iyon? Ductile or brittle? Hello?
Ductile
Okay.
po, ma'am.
Okay, correct. So, this is ductile. Okay? So, from ductile, we are able to know naman ngayon kung ano ba yung gagamitin. Soderberg or Goodman. Okay? So, alin po ang gagamitin natin? Soderberg po ba or Goodman?
Soderberg po, ma'am.
Okay, correct. So, Soderberg, since this is a ductile material. But then, the Soderberg equation has two forms. one in form of sigma, the other one in form of tau. Okay? So ngayon, pipiliin mo naman between these two kung alin yung gagamitin. And that would be dependent on the type of loading. Okay? So in this particular case, this is under torsion. Okay? So torsion po ito. So we have variable stress, ductile torsion, therefore use Soderbergh equation. In what form? Okay, yun po in form of tau. So you will be using 1 over Fs equal to tau m over tau y plus tau a over tau n. Okay, so yan po yung ating equation. Bakit po ito? Again, variable stress. So Soderbergh or Goodman. Okay? Ayun, natin ductile, so Soderbergh na lang. But then Soderbergh has two forms. But since this is torsion, you use yung pong in form of tau. Okay? And with this equation now, okay, hahanapin mo ngayon yung every component ng equation natin. Fs, ito na po yun. So it's given already. So you start with tau y, where your tau y is equal to 0.6 of sigma y. Okay? So, kunin muna natin, balikan na natin yung material specs para ma-solve po natin yung tau y. What would be the value of your sigma u? Okay? Sigma y and the BHN value. Kindly ano na lang po siguro, i-chat po natin dun sa box po natin, okay, for the values. Okay? Para makapik ko po. So, and then also the value of the onto what table and page number included po yun. Sigma U, Sigma Y, and BHN. Ano po table? Okay, so we have there 1 to 7, 114. Ano pa yung isa? $260. So these are the values taken from table 87, page 50. So these are the values, sigma u, sigma y, and BHN. And then for tau y now, that would be 0.6 of sigma y. Okay, so 0.6 of 114 KSI, that yields, ano po yung value?
68.4 po, ma'am.
68.4 KSI. So, i-box po natin, okay, yung kada component na i-substitute po mamaya natin to the Soderbergh equation. Okay, so yun po yung tau y. Let us have now yung tau n. Okay, so tau n. Now, yung tau n po is dependent on the life of the material. So let us take a look and go back doon sa ating sample problem. Okay? So tingnan po natin if this is to design based on indefinite life basis or definite life. Alin po ang gagawin natin? Definite or indefinite? Hello? O tingnan po natin. Paano po natin malalaman if you are given the number of cycles or number of repetitions? That's an indicator that you are to design based on the definite life. Okay? Kung siya naman po ay indefinite, so wala pong minimension na ganoon. So, in this particular case, okay, indefinite life po ito. Okay, so we have, okay, the value of the yung tau y. Okay? So, dito po ngayon, for the value of tau n, okay, so this would be indefinite life basis. Okay? So, indefinite. Okay? Since the number of cycles or number of repetitions, these are not, in the problem. Okay? So, for indefinite life, okay, you go back now doon sa equations natin for indefinite life for tau n. Okay? So, what is then the equation? Tau n is equal to 0.6 sigma prime n times the surface factor times the size factor. Okay? So, yan po yung equation natin. Yan po yung nakalagay doon sa torsion and indefinite life. Okay? So, hanapin po ulit natin kada isa dito sa equation natin. So, let us have first the size factor. Okay? For the size factor, you use 0.85. Okay? Again, dinamit po natin ito. Okay? Ang assumption po natin, yung dimension po na makukuha natin will be on a range of 0.5 up to 2 inches. Okay? So, ito po yung size range natin. Okay? Para po dito sa 0.85 po na yun. Okay? So, next would be the surface factor. So, saan po natin makuha yung surface factor? You use figure AF5. Okay? So, you go to figure AF5. Okay? So, kailangan po natin doon is the value of your sigma u. Okay? So, din po natin tingnan. Okay? Yan. This is figure AF5. Ano po yung sigma u po natin? Sigma u is 127. Okay? So, most probably, dito po in between 120 and 130. So, this is half. And then half po noon. So, most probably, dito po yung 127. Okay? So, nasa pagitan po nila. So, you estimate po, nasa yung 127. And then, ano po ang type ng surface? Okay? So, wala po ulit na mention dito na type ng surface kung anong gagawin natin. You assume machine. Okay? You assume machine po. Okay? So, with that assumption and using your figure AF5, okay, you find value of the surface factor. Okay? Ano po ang surface factor?
0.83.
Okay. So, yung pwede po mabasa natin dun is 0.82 or 0.83. Yun po yung pinaka-malapit natin na estimate. So, surface factor equal to 0.83 taken from figure AF5. This is on page 21. Tama po ba? 21 nga ba? 22?
21 po, ma'am.
Okay, tama. Okay, so this is the surface factor. Next would be yung sigma prime n. Okay? So, sigma prime n naman po, okay, that is dependent on the type or the classification of the material. Same thing with the BHN value. Okay? So, you look at the BHN, this is 260. So, BHN, less than 400. So, you use here sigma prime n equal to 0.5 of sigma u. That is when BHN is less than 400. Okay? So, sigma prime n, okay, is equal to 0.5. Sigma u is 127 KSI. Okay? So, this would be equal to 60, ano value nito? 63.5 KSI, correct. Sigma prime n, okay? So with these values po, okay, with these values, you can now find the value of, okay, tau n, okay? So again, from the equation, tau n is 0.6. Value ng sigma prime n, ito po yun, 63.5 KSI. Then, you have the surface factor, 0.83. And then the size factor, 0.85. Okay? So, kindly compute po for the value of your tau n. Okay? So, sinubstitute lang po natin yung mga nakuha nating kanina. Okay? Na values. So, what is tau n?
Yan, Andre, okay na gano'n.
Okay, so we yield tau n equal to 26.87955 KSI. Okay, so we include po na yung real value. Okay, so iwasan po natin yung mag-truncate ng value because this will affect the final answer. Okay, so ito po yung ating value ng tau n. Okay? So, ano na lang po yung wala doon sa other words? We have here tau y, tau n. So, yung dalawa pong nasa numerator po. Okay? So, yung pong letter A, ng the question po ng the sample problem, you are to obtain the diameter if torque is reversed. Okay? So, una po, torque is reversed for letter A. So, yung pong type of variable stress, that affects only the value of yung mean at saka po yung alternating stress. Pero yun pong atin na endurance, okay, and yung taway, hindi po siya naapektuhan po. Okay, again, ang type po ng variable stress will affect only yun pong tau m at saka po yung tau a, the mean at saka alternating. Okay, so for torque is reversed, okay, ano po yung property kapag torque is reversed? Yung tau m is equal to 0. Ari po ay na-derive natin kahapon, okay? If torque is reversed, tau m is equal to 0. And what about the value of tau A? Tau A would be equal to tau maximum. Okay? And what is tau maximum? Since rin po ay torsion, okay, ano po equation natin sa torsion? 16t over pi d cube. We are looking for tau max, so I'll be using here t max. Okay? So 16t max over pi d cube equals your tau A. Now this is 16. T max, we have the value 4.165. 4.165 kip inch over pi d cube. Okay, so try to simplify. 16 by 4.165 divided by pi. So, ang matitira na lang po sa ilalim would be d cube for your tau A. So, ano po yung nandun sa numerator po? Okay, so for tau A, we arrive at 21.21211708. Okay, d over dq. Okay, so this is the value of your tau A. So we have now completed the components of your Soderberg equation. So let us now try to substitute. Okay, substituting to Soderberg to obtain the value of dq. Okay, so 1 over fs is 2 equal to tau m is 0 over tau y 68.4. Okay, plus your tau A, that's 21.2121708. 2, 3 ba yun? 2 or 3? Ano ba rin sulat ko? Over, okay, 2. Over d cube, okay? And then ano yung nasa ilalim? It would be your tau n. And what is the value of tau n? 26.87955 d cube. Okay? So this is now your substitution to the Soderberg equation. So 0 over tau y, okay, this will be equal to 0. Okay, so 0 na po ito. So matitira na lang is 1 half equal to this value. Okay, 21.21 divided by 26.87955 d cube. So from there, you can obtain the value of the diameter. Okay, so paki-compute nga po natin what is now the diameter. Try to simplify, then find the diameter po. Okay, so we yield an answer 1.1643 inches. Okay, so from our computation, ito po yung sagot natin. Now, ito po yung sinasabi ko kanina that yung answer po natin, palagi mo po yung i-evaluate. Tingnan mo po kung gumamit ka po ng size factor. Kung gumamit ka po, titingnan mo ngayon yung answer mo if it is within the size range. Okay, katulad po nito. Gumamit po tayo dito ng size factor na 0.85. So, ang inaasahan po natin, our answer would be on a size range of 0.5 up to 2 inches. And look at our answer. This is 1.1643. Luckily, nandun po siya sa size range na iyon. So, ibig sabihin nun, tama yung size range na size factor na ginamit natin and tama din yung diameter po natin na nakuha. Ito po yung kapag ang nakuha natin ay wala dito sa size range na iyon, we need to recompute. So, pag nag-recompute po tayo, alin po yung mababago? Yun pong value ng tau n kasi yun yung may kasamang size factor. Gagawin mo ito ngayon equal sa 1. So, ang mababago po ay tau n but then all other components, hindi na po siya mababago. So, mababago lang yung dimension mo dahil nabago mo yung tau n. And that is to be substituted to the Soderberg equation to find a no answer. Okay? So, yun po yung gagawin. At kung ano po yung makuha natin on the recomputation, edi yun na po yung final answer. But in this case, we do not need that. Okay? Kasi it is within the size range. Okay? So, you need lang po to convert this to the standard size. And what is the standard size? That would be, I think, 1 and 1/4 ba? Okay. So 1 and 1/4 of an inch. So that would be our answer for letter A. Okay? We use 1 and 1/4 of an inch. Okay? That is when torque is reversed. Okay? So kayo naman po yung gagawa ng letter B at yung letter C. Okay? Yung letter B po, ano po yung B? Ito po yung repeated. Okay? At ang letter C po, ito po yung fluctuating. Okay? So, paggawa mo po ng B and C, hindi na po mababago itong ating tau N, tau Y, okay? Because these are not affected with the variable torque, okay? Hindi naman po siya yung nababago. It is simply the torque that varies. So, alin lang po ang affected nun? Yung tau M at saka tau A lamang, okay? So, yung solution nyo po, parehas pa lang din po hanggang tau N. So, dito po sa parte nito, dito po sa A na yan, yan po yung papalitan mo ng B. Ano yung sa B? Torque is repeated. Okay? Sa C naman, torque is fluctuating. Okay? And then you find new value of tau M, tau A, and then substitute again to the Southern-Bridge equation. Okay? Again, look for your answer if it is within the size range. Okay? Can you do that? Hello? Okay, so paki-ano muna po, paki-solve po muna natin and then later, okay, I show to us po yung inyo pong mga solution. Okay, sige po. Work on letters B and C muna po. Okay, I have shared to you yung Jamboard where you can place your solution po to B and C, okay, of the sample problem. Okay, so you're done with this ano po, module. I'll shift po the presentation doon po sa Jamboard po natin. Okay, so let us have your answers po. Who wants to volunteer to show yung kanyang answer for letter B? Just raise your hand na lang po. Who wants to answer? Hello?
Sagi. Kanina may naluto, no?
Asan yung work ng iba? Ba't wala dito?
Okay. Let's check. Oras pa. Kapal. May mga kayo ng
Okay, Christian Carl.
Yes po, ma'am.
Hello. Okay,
Yes.
letter B.
Opposite work.
Sige. Letter B po. Sabi po ang i-explain po, ma'am. Tama po.
Yes po.
Sabi po ang ano po ay torque varies from 0 to maximum. Ang nakuha po nung una po ay na para po sa tao ay 68.4 KSI, para po sa tao N ay 26.87955 KSI. Para po dun sa tao M po ay equal po siya sa tau max over 2. Tapos po ang value po ng tau max ay 16 torque max over pi d cube all over 2. Tapos po nung sinubstitute po yung max torque na 4.165 kips inch, ang lalabas po ay 10.68541. Tapos over d cube po, yun po yung value ng tau m. Para naman po sa tau a, same lang po siya sa tau m, which is tau max over 2 po. Kaya po yung tau a po ay 10.608541 over d cube. Tapos we substitute po siya sa Soderberg equation, which is po yung magiging po siyang 1/2 equals to 10.60 over d cube all over 68.4, which is po yung tau y, plus 10.60 608541 all over 26.87955 times d cube. Ang makukuha pong diameter po ay 1.03205357 inch. Yung standard size po ay 1 times 1 over 8 inch. 1/8 inch po.
Okay, thank you. Question. Okay, so we have here 1 and 8 for the answer in letter B. Okay, so again, B is repeated. Okay, and the property of repeated stress. Okay, tau m equal to tau a, which is equal to the maximum divided by 2. Okay, so ito naman po natin doon ang solution. Here we yield an answer 1.032, which is within the size range. Okay? So no need for us to compute. Okay? The size factor 85. Okay? So tama po yung ginamit natin. Okay? So let us have letter C.
Pero papagamit ko sa kanila yung
Okay, ito, Beo. Emmanuel ba ito? Hello?
Hello po, ma'am.
Emmanuel. Okay, sige. Let us have letter C.
Rinig ko
Your
ba?
answer. Yes po. Okay, fluctuating. Okay, you may start now. Emmanuel? Hello? Mr. Emmanuel?
Rinig po ba?
Okay, sige po. Oo, yes. You may start now.
So, sa C po, sa C po, fluctuating stress po yung sa atin, and ang minimum po niya ay ang minimum, may binigay pong minimum na na torque, and ang minimum po ay 2.876, and then sa tau y and tau n po, magre-remain po yung ating value from letter A po. And then sa tau m and tau a naman po, kailangan po natin siya i-solve. Sa tau m naman po, ang formula ay tau max plus tau min all over 2. And ang formula po ng tau max natin and tau min ay 16 T max all over pi d cube. And then substitute lang po natin yung value, magiging 16 times 4.165 all over pi d cube plus 16 times 2.876 all over pi all over 2. And then sa tau max po, ang nakuha po natin ay 17.92975927 all over d cube. And sa formula naman po ng tau A ay halos similar po ng sa tau M, pero ang nangyari lang po ay naging minus yung sa numerator. And ang nakuha naman pong value ay 3.282411546 all over d cube. And then para po makuha natin yung size, meron yung ginamit po natin yung formula sa design stress na 1 over Fs equal to tau M all over tau Y plus tau A all over tau N. And ang nangyari po ay 1 over 2 is equal to 17.1297597 all over d cube over 68.4 plus 3.282411546 over d cube all over 268755. And ang naging sagot po ay 0.9159819689 inches, and sa standard size po niya equivalent po siya sa 1 inches. So ang sagot po ay D is equal to 1 inches.
Okay, thank you, Emmanuel. Okay, so here, diameter for letter C, okay, is considering the minimum and the maximum value of the torque, okay, we yield there an inch for the diameter. Okay, again, the diameter is within the size range, so the use of the size factor 0.85, okay, ay ano po yun, tama po. Okay, kaya we yield here this answer 1 inch. Okay, so just a ano lang po on yung work po ni Emmanuel. Okay, so better to have, okay, although this is still correct naman po, okay, better to have a value of your tau maximum, tau minimum, have it answered muna po, okay, para po iwas din tayo doon sa mas prone na pagkakamali, okay? So you may compute separately what is tau max, tau min before you have the value of tau m and tau a, okay? Kasi ito po, kumaga carry over, okay? So hindi na kinuha muna the value of tau max and tau minimum, okay? But then this will yield the same din naman, okay? Hello? Nakuha po ba? The others, they yield the same answer po, 1 inch.
Yes,
Okay, so good. Okay, so do you have any question with the sample problem and yung ating variable stress analysis without the stress concentration? Okay, so yan po ay without. Okay, since the members appear without any surface discontinuity. Okay, so basic of this would be yun pong foundation doon sa with stress concentration. Okay, so okay, if you do not have any more yung question po, okay, those who haven't submitted their work may still do so. Okay, so I'll stop now the presentation, and then a quick attendance check. I'll call Mac. Hello. Okay na? Hello? Okay na po.
Wait ko lang po mag-open ng comment box.
Okay.
Okay po. 1, 2,
Okay.
isa pa po. 1, 2, 3.
Salamat. Okay, thank you. So,
Thank you po,
I'll
ma'am.
end the meet now. Bye po.
Thank you po,
Sige po,
ma'am.
ma'am.